Chapter 6, to your left, please. This is our normal distribution function. You don't have to write this down. You have to remember this one. We're not going to use the actual function itself, but we're going to use this idea. Remember, this is what we get for our bell curve looking thing. But here's the interesting part. All normal distributions effectively look the same. And this figure, 7.7 on page 238, isn't even scaled with numbers on the x-axis. It's strictly scaled in terms of the average and standard deviation. So regardless of what the mean is, regardless of what the standard deviation, I'm going to get this bell shape. And over here on the CDF, at least on the y-axis, we have 0 to 1, because as we go from left to right, we're building up a cumulative version of what this is. So what the y value on this right-hand picture represents is the total area under the curve from left to each given spot. So the y value here is the area under that piece. Y value at this spot is the area to the left. But even if I look at two very different data sets which are normally distributed, the left picture here is the diameter of a golf ball in millimeters. The right is the scores on the CPA exam. Those have nothing to do with each other, except for the fact that both sets of data come from normal random variables. The curves are exactly the same up to scale. So really the question is, when is a variable normal? When is it something else? Right now, all our something else is uniform. It's the only other distribution we have at the moment. But when is a measurement normal? And this really depends on a couple of things that we can look at in terms of the question and the population that is answering it. Do we have one mode? If you've got bimodal data, you're not going to fit that bell curve. You're going to have two separate peaks, each of which is a similar height. So I wouldn't have something that looks like a bell curve. It's got to be symmetric. The tails have to be getting smaller as we go out. It's got to have those basic characteristics to be normal. If you go out, what's it say on the side of that, Nick? How big? 5 fluid out, right? Because seriously, that doesn't mean that just time is a bottle. Some of them will be overfilled. Most of the time, it's going to be right around 500 milliliters. Higher, small, really small. High versus low. So I would expect water in one of those half. I buy a of ball bearings. Those ball bearings are all right up to size, and the chance of one being a little of a low as there is a high. How long did it take you to fill out your you finally got it? A while, right? Would you expect that to be, or many people take a shorter? What would aha? Most people probably completed, but then there are those right, done in 10 minutes. Long tail side and a short tail skewed distribution. It's normal. Insurance claims, auto insurance collision claims. Expect that to be or skewed one way or right. You're not allowed to drive without. That's true, but I'm talking about on the is going to be expensive. Expect expensive claims as expensive claims, or more cheap claims. Because I'm sorry. To the cheap side. So you think there'll be more accidents? Very high side. I go to the grocery store. I every box of cream cheese. A lot of this. Normally distributed. Well, just as much of an overfill. The chance of being in the middle and being out extremes, and I expect the symmetry of being happy saying we're going to use this function. And that is because that's the Excel. Just as equally, the distributions are all here. Yeah. Normal distribution. Now, the command is a little more way. Give the x, the mean, and the just like up there. So, what a particular chance is, I can Excel to do that. This you get the CD all the way up to whatever number. But when I Excel stages. So I didn't telling you in order to use, we have to look at standardized data. Let's go back to a small change. I'm changing to be 0. Standard deviation. Page 41 shows the exact same picture. Mu's and sigmas here, I just have the numbers from -3 to 3. The functions we were water bottle, diameter of golf ball bearings, those were normal distributed ideas and deviations. Particular, how do I get from to U? Turns out there's a you can choose to get X is fairly straight. A average down standard, so it makes the unit. You can do this transformation on any data. And instead of dealing with amount or amount of the standard norm, you do this. That actually allows is the curve one. We are not doing calculation part. And the who already did all that. Probability. The next are is understand I put it into Excel here. All right. Is this if I know Z value decimal places over there in give me a number 0 and 3 places. 2.00. down here to the 2.0 part, and I go second decimal, the amount 2.0 is 4.72%, which means zero. Excel, nothing but look. 0.96 is 0.75. As we get closer to numbers, because I'm accurate, and that's half. The other side is this graph is a mirror. So I really to your and you can have this table for today. Don't worry about working in Excel. It's in the data for the appendix C in the book. I would know the chance and the 0.5. How do I find? That's 0, 0. And I want 0. So I'm going to go here. The first is the 5. And 5, 1, 9. And I've made it about it, but that's why which decimal. We do this one and then. So now freak out a bit. This table. The corner. And upper right corner. A normal view with part of it shaded in, right? At the bottom of that and Z, right? number is this number, the number that we're reference this number. So I want special about the shape was symmetric. 0 is exactly, that means this number. Hey, what the? Going from -1 to 2.5. Wait, I can think of this as two separate. The this graph. Label these on A, B, and then this is as each of those areas. Using my tell me how. And there we are, 0.482. 0.1, 1, 2, 3, 4, 484. A, what do I have to do? Negative. Negative numbers. What do I do? Version. So I go to 1.2. 1, 2, 0, 1, 2 is deviations to 2.15 standard deviations above. Only one number. Draw me a picture. Draw your normal shade in the part you want. What's your underneath? In the middle, isn't it? Right to the left, right. My table. Almost. One. How much air is the whole thing to add up to? So this side of it, half for the whole thing, whole side it in the area. So if they need to do any calculation, I just have to remember it's symmetric. I need to go on. Which gives closer for being less than 0.972. Just add those two together. Yes, sir. Yes. Because remember, the chance using less, those are the same. One more. Is picture. What's the part I want shaded? Houston, problem. The table only allows me to find areas that start at 0. Not sure it's this and I subtract. Now both numbers are in my table. I use 2 to use that 2, 4, 7. Right? Please tell me I did the arithmetic right in my head. We can do this 2 different. Drew, isn't it? To the right. My table doesn't do this. So 0 to whole. Of the picture, the whole is 1, so this half of it, and then I take away leave. Let's see, that's 028. Somebody really small being above. What's the I said we could do the base. Sneaky ass. The other way we could have, we work out this entire two was, wasn't it? There I would use one number. Other U. Also, I 1%. I don't know what this is off the top of my picture I want. The picture I want in, so this area is 0, 0, 1. I want to know that value. Find that. .49. So if you can 49 or the closest 49, 0, 0, the right area. So I start looking. Here we are. 0.49. 2.2. Table here. For our table, 2.3, column 0, 2, and 3. Oh, I can do the between top 2%. I could do the same thing. I could work out what the run is, and then I appropriate done often enough that there's a table on if you want with a Z 2.33. You want the top 196. Now please notice that little bitty at the middle, if the top 2.5%, that would be 2.5% in this, 2.5% in this. Well, that means the middle 5%, and 2.5. One there are times when I want to work this thing backwards. That is called the how to do it in Excel as a command. But I am using this blessed picture all the damn time. Shade things. What part I need values across the bottom here. In the appendix is the CDF version. I must tell you, almost always the version. If I'm looking oh, it's under the book. Says in there's an inverse in Excel. Standard deviation. And if you inverse, you use IV, then the error standard deviation. It's no less, and then you just dot F using the standard. The not to give it a standard. This is why I care how to solve the function, because one only have to worry about one option. Problem setting is a normally variable with a mean of 200. deviation of, where did I get of caloric oil analyzed? This is what they. This is how. What is it? I go buy an Egg McMuffin. Calories in. With a mean, I only have a with 300. That. This mean, and I divide deviation. 10, 14 places, calculator people. I'm sorry. Figuring out and even Z. What's areas at calculation? Doesn't it? I don't need this number. That's only add point. Go into Excel. Norm dot dist and the Z value. would make a version. If I give it a 1, places here. Also do norm 390 is easier to enter and explain. We'll wait until late. Bring it up. I have stuff for you.